Grounding electricity flows the path of least resistance, protection against stray electric currents due to shorts or other faults in electrical systems usually can be effectively provided can be effectively provided by arranging for a previously determined safe path for the stray currents to follow to the ground, regardless of the quality or insulation in electrical equipment. And there always exists the possibility that these protection will break down and short the circuit. Ordinarily, fuses or circuit breakers may be dependent upon to a automatic disconnect the circuit if a short occurs. Ground fault disruptors. In order to optimize the protection against electric shock, a ground fault interrupter (GPI) or ground fault circuit interrupter is used. The GFI is a supersensitive rapid action power switch that is in a few milliseconds disconnects the circuit when it detects that current is leaking to ground. It in its correct application, a person may receive an uncomfortable but not fatal shock since the circuit would be interrupted before a lethal dose was received. Work areas, working spaces around electrical power supply equipment should be adequate for the comfortable performance of normal operating and maintenance tasks. Secure footing should be certain when the equipment is exposed while in service. Illumination should be adequate, at least 50 foot candles in work and an auxiliary. Power system should be provided, that is storage batteries to supply lighting circuit in these work areas in the event of an emergency shut off of the main power supply. First aid, fire extinguishing equipment suitable for use on electrical fires should be readily available in suspicious locations. Hazardous locations operations where flammable vapors, gases, or dusts or explosive substances are present, or locations where such materials adapt to occur in flammable concentrations require that electrical equipment, that is switches, motors, wirings and so on, be safely installed so as to reduce the possibility of arc sparks or overheating causing the ignition of the materials. The specifications of OSHA 1910 for electrical wiring should be considered the minimum requirements for such situations. Conductor wires, when exposed to corrosive damp conditions, it should be of a type that is resistant to the exposure. Particular reference to the employment of portable lamps in damp places is merited because of extensive use of this equipment. They should be equipped with a socket of non-combustible, non-absorbent insulating material, a handle and approved cord protected by a non-absorbent insulator, and a basket type guard to protect the bulb. Storage batteries. Storage batteries, when being charged, evolve hydrogen, a flammable gas, as a product of the chemical change that takes place in the electrolyte. In some cases, the gas may accumulate in the battery to such a degree that when the caps to the battery cells are removed, the electrolyte, which is composed of a strong acid, that is sulfuric, will spray out of the opening. Care is required, therefore. Maintenance operations on storage batteries. Rooms for enclosures where storage batteries are charged should be ventilated to remove explosive gas concentrations, unless it has been determined that there is sufficient ventilation to remove dangerous accumulations of gases. Smoking, the use of open flames or of tools which are not manufactured of non-sparking metal, non-ferrous, and power tools should be avoided in the room. The electric system, that is wiring, switches, ventilation, fan, motor, and soon should meet the specifications of National Electrical Safety Code C2 for this type of hazardous location. This code is among those obtainable from the American National Standard Institute.